Welcome to another episode of Xa Talk Show. Today is 2020, September 10th, Thursday, 10 o'clock in the morning, San Francisco time. And today we don't have a topic. The topic is going to be either I'm going to code some Emac Lisp, or I'm going to do some JavaScript. I'm going to look into the Deno platform and to run some TypeScript and check out its libraries. I think I would like to do that. Or we're gonna talk about keyboards, random keyboards, keyboard stuff. So of you here, pick a topic. Okay, what do you like to listen? Pick a topic. Sergio and Bart. And today, there's a California fire going on all over the place, and the sky is red. It's very dreary. It's very dreary and depressing. So today the background image. So let me show you the background image. The background image is this one. The math graphics gallery. Okay, so you go there. Let me talk about mathematics. That's a fantastic topic. Now this is called stereographic projection. And the picture in the background is the one at the bottom. You see, you begin with this image, then you do the stereographic projection, then project them onto a board, then you get this. That's the background image. So how does it work? It works like that. So imagine a sphere sitting on a floor, then at the top of the sphere is a point, let's say the light source. Then so any picture on the floor can have a one-to-one map to the sphere by projecting a line from the top of the sphere to a point on the floor, and vice versa. Any point on the sphere corresponds to one point on the floor. So this way, if you have an image, let's say a photo of yourself or a picture, anything, you can project it onto the sphere, and vice versa. If you have a ball, a beach ball, whatever pattern on the ball, you can project it onto the floor. So this is a stereographic projection. That's part of the math topic, and this topic is very important. It's basically the core of what's called complex analysis, complex numbers. Okay. So it's quite interesting how, if most of you know a bit about complex numbers. You have imaginary numbers, it's part of algebra. You have the square root of -1. But however, then it's tied. It's very interesting to see that it is actually tied to this geometry thing, projective geometry. I mean, projective stereographic projection. Now the word stereographic projection is a bad jargon, because what the fuck does it mean, stereographic? It's not, when you see the word stereographic, you imagine it being three-dimensional, like realistic. That's not. So the jargon is pretty bad jargon. It would be better to call it spherical projection or something like that. But however, you cannot do that because math has its own history. You cannot just change a word arbitrarily or change some concept to a new jargon, because then it creates whole tons of more confusion. But anyway, so this is known as stereographic projection. You basically just project a sphere onto a plane. So we got some pretty pictures. All these graphics are done in Mathematica. In what year? 2006. Okay, I did them in 2006. Mathematica. You can do them in JavaScript today. It would not be too difficult. Shall we try to do that in JavaScript? Actually, if we do this, I cannot finish it in 1 hour. It will be 2 hours or so. I haven't done this for a while. So beautiful, stereographic projection, part of complex analysis. Good morning, Cortez. So Bart says, I think you need a low-pass filter when recording. Low-pass filter, you mean filtering out the electric hum, So I have, I'm looking for the answer. I have electric hum in my live stream, in the background. But it does not happen. It does not happen with the same equipment when I was at my old apartment, like 3 months ago. If you watch my old videos, you don't have the hum problem, but a hum problem, I have a hum problem here. So I don't know how to fix that. Does anyone know? Anyone know? Any one of you who are electronic nerds, resistors and capacitors and ohms and amperes. So any of you know that answer, I would appreciate. How do you fix the hum? Okay, I don't want a generic answer. Okay, it's like, supposedly it's called ground loop hum. So anyway, I'm talking random. So today the topic, let me repeat. The topic should be me coding Emacs Lisp live, or me exploring JavaScript, the Deno platform, looking for its libraries. I'm gonna, do it live, or we're gonna talk about keywords, random topics about keywords, or I'll just go on. Okay, so if you have something you like to, type it. Okay, Michael Edwards, good morning, and Elderio. So we were talking about electronic hum in my background. It's called ground loop. Ground loop hum. So yeah, I heard it's ground loop hum, but if you try to read it, it's like you're gonna spend hours. So I want someone who has experience with, doing live streams, and who has experienced this, who can just tell me, oh, you need a new speaker, or you need a new microphone, or you need to unplug this and plug it somewhere, something like that. Okay, don't just tell me, oh, ground loop hum. Okay, so what are we going to talk about? Let me talk about random math then, since I guess. Hey, good morning, Justin Scarfi. Now, Justin Scarfi, he is here. Now, that's scary because he is a professional mathematician at a university. So now he puts a check on my to be discussion of math, because someone is watching. He would know the right answer. Okay, so let me talk about math. Okay, some general educational beautiful mathematics for those of you guys programmers. Programmers are typically ignorant of math. So Bob says, your opinion on using many different random libraries instead of writing your own one for your app. My opinion, okay, I can talk about that. Okay, libraries, it all has to do it started to go downhill beginning with the millennial generation. The millennial generation. That includes you, but. So let me tell you about libraries, programming and libraries. So let's say before year 2000s, okay, before year 2000s. Now we are programmers, right? We program, and there are libraries. So basically every programmer knows about libraries. Libraries is a, someone wrote a package, a set of functions that to do something useful, and not everyone has time to do, to write everything from scratch. So there exists libraries. Someone has already wrote that. For example, a library for matrix computation, a library for string manipulation, a library to process HTML, to parse HTML, and so on. A library to do cryptography and so on. Tons of libraries. Because there are thousands of tasks in programming. So libraries are very useful, and someone wrote it. So I'm saying in the, let's say, at least before year 2000s, every program, you don't have to, so there are libraries, you know what they are, so you use them. You don't necessarily know how to write them, but at least you understand the entire context. Why are you using it? You know that this library is is designed to do this particular task. So if you are working in a company or for yourself, you have many tasks, A, B, C, D, E, F, G. So you code some, and okay, for the task B, you might know that maybe there's already a library written by someone that will does B. So you download it, install it, and you use it. This is a normal situation. I would say, this is that's a situation. But let me talk about today's situation. Today, this millennial generation, especially JavaScript programmers, these fucking idiots, these people, they have no idea what is a library anymore. Okay, a library to them is just something on the web. You just type this line and you just download, and your code will work. They have no idea what is going on. That's today's JavaScript programmers and the Ruby programmers. Starting around, I would claim, let's say 2010. Okay, starting around 2010, that's the situation. So let me go into details. What's the problem? So like today in JavaScript, you have a library that's just five lines of code. 1, 2, 3, 4, 5 lines of code that does string, like left pad. 5 lines of code. What the fuck? Who the fuck doesn't know how to write that? I mean, you see, library, the purpose of library is to save your time. Usually it's a task. Someone has dedicated their their time to write it. Takes a week, takes several days or a month to write a library. So you are a programmer, it's useful. You separate things into packages. You have libraries you can use. But today it's quite different. Okay, today there are libraries, especially in JavaScript land, that exists. That's just 5 lines of code. Now, if you are a programmer, if you don't know how to write that, I mean, you would be a fucking idiot. You should not be doing programming. But okay, the thing here, the major thing is that you download the library. That's 5 lines of code. That's trivial. So the time to maintain that library, to keep that library around, is actually it takes more time. You waste your more time than actually writing that code yourself. Just 5 lines of code. This happens in the JavaScript land. npm, the npm, the boss of npm, Isaac. I think he's not a good human animal. He created this situation for the purpose of benefiting, making himself more popular. That is my opinion. Okay. So today the library, the programmers, they don't know much about programming anymore. So they don't even know, they don't know what is a library. They lost the general sense of things. Why does that happen? Well, part of the reason is programming. As technology progresses, programming becomes more. We have lots more technology, and these companies, they need people. They need people to code it. So it would benefit these companies if there are huge number of people, programmers, so they don't have to pay high salaries for very few nerd programmers. So companies create a situation basically they want everyone to be programmers, and they want you to be replaceable. They don't want someone who like knows a lot or has a lot of opinions about something. They want you to be cogwheels, so they can, they can pick you and kick you out and replace you with someone else. Like you don't matter. You don't matter to these corporations. That's the condition. That's what generally what corporations want. That because that benefits them that way. So because of that, and because the tremendous progress of software, technology, because everything becomes computer, because computer becomes more and more important, and AI technology and so on. So you need more programmers, and then the programmers, their knowledge and their ability kind of degraded in general. Okay, generally speaking. And so libraries, I would say that is the situation. Okay, I think that's about that for that topic. So what says, especially in the JavaScript, so many random libraries are used even for the simplest tasks. That's right. But each library has their own risk of breaking the project that imports the library. That's right. And this situation is particularly severe in the JavaScript community, and in particular the npm ecosystem, if you might call that, the npm system. Why is it that way? In part, it's because it's created that way, because these corporations or these npm leader, they want it that way so that they benefit. They can become more rich. Okay, that's part of the reason. Okay, there are other reasons. There are other more. There are less. There are other reasons that's not as dramatic. You know, because we there's more and more computers, and technology progresses. So good morning, Senze. Good morning, Freddy. Good morning to Germany. Came just right on time for a rant. Okay, so that's about that. I don't know what I have an article on that actually. So if you just search for, okay, so it's Emacs stuff, XAR start command log mod. Oh wait, shit. Okay, so back to, so here you can see all my commands in a pink window. And let's type for XAR library. Okay, there are some articles about that, but I don't think I'm seeing the one I want to talk about. But anyway, there are some other articles about libraries. So this one is actually quite popular. This one is not written by me. This one is written by David Barr, and this one is, the title is "Why LD Library Path is Bad." That's one of the technical environment variable in Unix and Linux, and this article is written around year 2000. So I talked about this before. So back then I was working at Natopia, and we write server software, e-commerce server software, one of the first, and I was responsible for I'm part of dev team, and I'm also part of the DevOps. What you would call it DevOps, but DevOps back then doesn't exist. That word doesn't exist. You are just called sysadmin. So I'm doing both. And one time when installing and testing our software in a staging server, you got this bug, and finally I traced it to the LD library path. So I found this article written around 2000. Written around 2001. So but the article is dead. You cannot find it on the web anymore. So I copied it and put on my website. And since then, this page has been very popular. You'll see this if you just search this title, you'll find it linked in quite a lot of places, on Stack Overflow, on database forums, on lots of places. So this is part of the Unix problem. The Unix Linux people, the fuckheads. They don't understand. So this is a major problem. This is a major technical problem of Unix, in particular, the concept of environment variables. Environment variables should be banned. They create more problem than they solve. They should be entirely banned. So never ever use environment variables. Okay, if you that's my advice. If you like what I do, if you like my style of thinking, never ever use environment variables in your system. So, like, for example, if you are Linux or BSD or whatever, or Mac OS, you're doing something, it tells you, oh, for Ruby or Python, or alternatively, you can use this environment variable. Don't do it. Avoid environment variable as much as possible. It's not entirely possible, because this is part of what we have, the technology. You cannot just throw it away, but try to avoid environment variables as much as possible. So why is environment variables bad? Because they are essentially, the essence of environment variables is that they are global variables. Okay, global, I mean, if you are a programmer, then you already know how bad is global variables. That's what environment variables are. And then you have a bunch of dot files. Anyway, so I recommend don't use environment variables. Okay, now if you have to use a file, the dot file is even better than like config files. Use config files to avoid environment variables. And even better than that is just avoid that at all, like no variables. So every time you call a library or something, let's say every time you call some kind of bash command, you just make sure that you put every argument, I mean every parameter, in the line. Okay, don't use environment variables. Yeah, I know some of you will say, oh yeah, but that's too many arguments. Well, you can do it. So, okay, Bob says it's hard to follow that advice from a Kubernetes perspective. It is based a lot on environment variables, and even if you don't use them, then you still depends on constructs very similar to environment variables. Okay, that's a point. What do you mean by depends on constructs very similar to environment variables? That's the thing. What do you mean by similar? But essentially, you don't want global variables. So Bob says if you work with Kubernetes, okay, I don't know what's Kubernetes. Okay, let's look up Kubernetes. Let's see Wikipedia. Yeah, fuck. Never ever donate to Wikipedia. Okay, they are, the guy is a scum. They are a millionaire. Never ever donate to Wikipedia. In fact, never ever donate to anything open source. Today. Now, 10 years ago or 20 years ago, that's a different story. But today, open source is it's extremely evil. And also Wikipedia. Do not donate it. Okay. Do not donate to Wikipedia. If you got money, keep it to yourself, and spend it. Buy stuff, whatever. Don't donate thinking, oh, I'm going to be a good person. No, you are fucking fuckheads. You are doing that just to so you feel happier. Meanwhile, you contribute to the misery of other people who are poor. Okay, Kubernetes. How do you pronounce it? Kubernetes, commonly styled as a K8s, is an open source container orchestration system for automating computer application deployments, okay, scaling and management. It was originally designed by Google, okay, and is now maintained by Cloud Native Computing Foundation. Crap, this scum. you know Usually all these non-profit organizations, just basically, in my opinion, regard all non-profit organizations as scumbags. Have you ever looked into all these donations? Like you might want to donate. It's good. It's a common good thing for programmers to do, especially if you work at Google. You have quite a few money to donate. You feel better. You feel you are contributing to society, to some non-profit organization, this or that. There are quite a lot of them. But have you ever looked, where did your money actually go? Or some organizations, they donate to Africa children. So Americans love these concepts. Donate. Where does have you ever looked, where does your money actually go? I bet, well, most of you have not. You just you're doing donation because it makes you feel happy, and that's usually all that's about it. And you are donating only like less than 0.1% of your money. If you are a programmer. Now, if you donate the big time, that would be a different story. Okay, if you donate, for example, let's just say even 1% of your income, just 1%. If you donate 1% of your yearly income, then that's actually something. But that's not what all these most people donate. Anyway, let's go back to the article. So it was originally designed by Google and is maintained by this org foundation. It aims to provide a platform for automating deployment, scaling, and operations of applications containers across clusters of hosts. Okay, this is a new technology, of course. Oh, it's written in Go. Fantastic. This is beyond me. I'm too old for this. This is 6 years ago. So this is a new generation thing. So I don't have experience. Kubernetes. Okay, it's cloud and pods, replica sets, services, volumes, namespace, config maps, and secrets, stateful sets, daemon. Okay, quite a few jargons. Well, I don't know. Are you working on this kind of thing, Bart? So Kubernetes. So Bart is saying if you're gonna use that, you are going to have lots of problems if you want to avoid using environment variables. Okay, that may be true. Yeah, okay, that may be true. Yeah, so okay, let's talk about something else. How long have I been talking? I've been talking for 30 minutes. Korean Lynch, Keenan Lynch, good day from Flint, Michigan. Oh, hi. Joseph Serge, good day from Ecuador. Hey, Ecuador. And Freddie, I have an article. Yeah, let's go back to my article. So we rambled about this Unix LB library path. Okay, they are I have an article that okay, I know where to find it. Okay, let's go to my programming blog. So this one is Clojure Instapass parser tutorial. I worked on Clojure about 5 years ago, and 2014, and studied this parser in detail, and wrote a detailed tutorial of it. better than its documentation. So I wrote the entire manual of this Clojure parser, Instapass parser. Okay, are they still around? Let's check. So it's written by this guy Eagleberg. Okay, so it's very good parser, but the documentation is not as good as I hoped. That's why I rewrote it. But okay, so anyway, so you see it's popular. It's got 2,000 stars and 128 folks. Okay, let's go back. So you go to my programming blog. Okay, closure tutorial. So well, I have lots of tutorials on many languages. You go buy it. Okay, you can buy my entire Xali website, or you can buy for example, I have JavaScript. Some of these are very good. Okay, JavaScript tutorial, Git, Linux, and Python. Okay, so I want to show. Yeah. Okay, so let's go to my coding programming blog. Okay, so go to programming, then go to technology. There it is, technology, past and future. So this guy says, you promised me Mars colonies. Instead, I got Facebook. Now, if you are old generation like me, you understand what this guy is saying, But if you are younger, you don't know. You don't know. So anyway, here I think I have an article here. Let's search for libraries. On the question of too many programming libraries, exponential growth of programming language libraries. Now, this is written in 2016 when I was a poor sob. I was living below poverty, below the poverty's poverty. So 2000, exponential growth of programming language libraries. So I'm right. This article is written with respect to, from a philosophical point of view, you look at humanities. One aspect, one endeavor of human animals. That is programming. The programming activity, and there exists this thing called libraries, right? Libraries existed long ago, like 40 years ago. So programming is an activity of human animals, and it's part of technology, and you have this concept of libraries, which is part of the programming activity. So I want to look, as typical of me, I want to look at the situation from a entire human animal's perspective, worldwide, and encompassing from the moment it existed to today, not fat. Okay, as in contrast to today's, most people, the fads, they don't know nothing. They just look, oh, this library, oh, this is a new language, I need to use this. Oh, did you know this new library? Oh, that's the fuck. Okay, so I have always been, doesn't matter what topic, I've always been interested. You want to look at the whole history and humanity's point of view. So I'm looking at, so I noticed, in 2016, wow, so there are so many libraries, like you cannot even keep up. Like this is different from 20 years ago, like in 1990s, or even year 2000s. If you are doing particular language, let's say C or Perl, then that basically there's a set of libraries, part of them bundled with the language, part of them outside of the language. Okay, but basically they are just a set that every programmer of this language, at least the good ones, will know. It's just these. Or maybe next year there's a new one, then okay, then everyone, we know about it if you are a good programmer of that language. So that's a situation back then, but not today. I mean, even doesn't matter what language. Even if you study hard, even if you dedicate your time, I mean, you cannot keep up. You cannot. You don't even know what's out there. It's like it grows exponentially beyond the possibility of your comprehension. Now that is the case, of course, in JavaScript, and that's the case probably in Python, in Ruby. And if you sleep for 1 year, next year there's 10,000 things you don't know. So this is from a overall historical phenomenon point of view. This is a phenomenon. This is new. This happened in humans' world. This is a new thing. This all of a sudden, libraries, like 10,000 of them, that to the point that even in a particular language, you don't know, you cannot, it's impossible to be aware of them anymore, even if you try. So there is this new phenomenon, and so I'm a blogger. I'm a blogger kind of a guy. I observe the situation. So I try to think about what is the significance of this happening? What is the significance of this phenomenon? Of all things, like how does it impact humanity? How does it impact programmer's life? How did this happen? What are the causes that made this happen? You think about all these kind of things. Like it's not like given. It's not like schoolwork. You go to school, you got a homework, and today's homework is to solve this problem. you know and if you don't know the solution, you look at the answer, or you look at Wikipedia. So it's not like that. This is open. This is philosophy. Okay, many people don't know. We have people talking about philosophy, but actually they don't know shit about philosophy. This is philosophy. Okay, this what I'm talking about is about the question of too many programming libraries. This is philosophy. But it's not. But this one, it's not a giant, a major thing. But anyway, I'm illustrating. What is philosophy? This is a philosophy. This is what philosophers do. Okay. So anyway, so on the question of too many programming libraries. So what is the cause? When did it happen? Why does it happen? What is the impact? What's the consequence? You want to study. You want to look. Think. You want to think. Think is a major thing. Think. The definition of philosophy is think. You not just think. Okay, it's not like you think about 1 minute and that's philosophy. No, you put your life to something and just think about it. You think for 1 hour today, 2 hours, 3 hours, 5 hours a day. You think about it every day. You keep thinking about this for 1 year, for 2 years, for 3 years, for 10 years. Then you are a philosopher of this particular topic. Okay, so you can do that with this topic exactly. What on the question of too many programming libraries. So and that's what philosophy is. Then you will discover this is not just about programming anymore, because once you dive deep, it relates for example, it touches on human habit, social structure. What kind of society, what kind of, for example, economic system in a society will create this situation, and maybe some other will not. And so it's an open question. There's no end to it. And also often it involves history, so you can dive. So for example, when you study this question on the question of too many programming libraries, you could, one of the question is when did library begin? When did the concept of library begin in programming? Try to find it. Try to, some people, today's, the millennial fuckheads and idiots, they like to say, or academics, they say, oh, where's your citation? I need citation. Okay, citation. Try to find the first citation, in academia or somewhere. or maybe it's etched in stone. Maybe you'll find on the Greeks someone's grave, 2,000 years ago. When did the concept of library begin? And does that qualify as programming? Maybe there's library concept before the programming. Of course, then there's linguistic aspects. For example, when we say library, where does the word came from? What do you mean library? Library is a place you go to and borrow books, right? So what the fuck is a programming language library? You know, it's not a place I can go and borrow books. So why do you call it library? Well, that's etymology. Okay, so of course then you understand. It's borrowed from the concept of physical library via analogy. Analogy is in fact how most words are invented. Okay, so anyways, let's go back to this topic. On the so I was so I don't remember what I said here, but let's see. So many libraries. So yeah. So among the question is how does it affect you? So this is a new phenomenon. So this too many so many libraries. This is a new phenomenon in society. It somehow just happened. It happened around, let's say, 2010. I mean, it doesn't happen just one day, but it's kind of like historians usually you put a specific date as a milestone, or some kind of to mark that day as as something happened. So you could say, let's say this began, I would say late 2000s. Okay, or we can just say, make it easier, 2010. We can say, okay, that's a time when libraries goes exponential. uh, and so one of the question is, I mean, like, how does it impact you, you as a programmer? Is this something you like? Does it benefit you, or is it good or bad? What do you think? So there are all sort of questions to ask. So okay, so in turn, we realized it's not just libraries; it's exponential growth of everything today because of technology. It's we, I might call myself a technologist, and you guys too, because we are interested in technology. All sort of programming languages, and computers, CPUs, or Intel, or what's the latest GPU, from NVIDIA. We are interested in our latest monitor, display ink technology. We are excited about that. So many, and AI, of course, artificial intelligence and machine learning. So, and quantum computing, of course. So there are many things going on, and so it's not just libraries. So we do know that this is exponential growth of almost everything. So human animals, we begin, as far as my perception is that human animals, we know nothing. We know less and less, and basically we know nothing. Each one of you and me, we know nothing. That is the correct answer. You know nothing. Now, if you believe that, then you are correct. If you don't believe that, then you are a fucking idiot. You are just another worm crawling on earth. Okay, I think that's it for today. Oh my god, I got 19 people talking about philosophy. Okay, so Bart, all the comments is from Bart. How long have I been talking? I've been talking for 45 minutes. We should shut down, since we talked about on this topic of philosophy. That makes it nice, just one topic, and we shut down maybe 5 minutes, in 5 minutes. So let's see. Okay, close that. Let's see, let's go to my video check, audio check. Xali monologue, famous Xali monologue. I know nothing. So Derek says, Derek Rods says the impetus of libraries is what was called code reuse back in the day. Too many libraries fracture effort is a trade-off. Too many libraries, too much fracture, not enough libraries. Okay, I think maybe that's it for today. Okay, so so that's that's the question. That's the thing. That's the article I was trying to. Since Spot asked about libraries, so I have an article on that. Uh, okay, mathematics, my true love. These are functions. You see these pretty pictures. Now, this is the beauty of mathematics. When you learn math at school, mostly it's boring, right? Oh, trigonometry, or calculus, or algebra, or XY, how to solve, that's boring. It's boring mostly because the teachers are not interested in it. You want someone who are enthusiastic, who love the subject. When your teacher, when you love the subject, may it be programming or math or chemistry or whatever you do. When you love the subject, and when you talk about it, you'll show in your emotion, and you will automatically do a spectacular job. So at school, most math teachers, I guess many of them, I guess majority of them are not that great. Because they don't love the subject that much. On the other hand, great mathematicians almost always love the subject. Okay, for example, the greatest mathematicians, or I mean, it doesn't have to be mathematician. It can be programmer, the pianist, musicians. Usually the greatest ones, they truly love the subject. So math, okay, so you learn in school the boring stuff, but here is the actual beauty. Okay, today today we have seen the stereographic projection. Now this is about complex analysis. Okay, why? Well, I can actually do a tutorial. I think I did one, but it's pretty lousy. I need to practice teaching math, and also I haven't been doing math for a long time. But for example, this stereographic projection, I can wait. What happened? So I can go into detail. So you can understand how does this why does this have to do with complex numbers? How is it so interesting? And similarly, what for all these, for example, this Mathematica I wrote in 1997. This is what Mathematica language looks like. Okay. Now, you Haskell fans and Scheme or Lisp, get out, because Mathematica is like 10 times more advanced than whatever your Haskell or whatever. So I wrote this in 1997. This one is doing plain tiling and patterns and symmetry. There's huge amount of math of it. Today, I can write this in JavaScript. Of course, it'll be more lines and it'll be harder, but it's doable, and actually quite a few people have already done that. For example, you look at the JavaScript 3D.js library. That guy is done lots of these, and many other people have done using JavaScript. I'm kind of getting old. I want to write, for example, I want to rewrite this in JavaScript, but it just delays and delays. I'm getting old. That's really what is happening. That does happen. I mean, on the surface, I don't see any reason I why not, but it just it's just not happening. Anyway, so all these are in Mathematica. These are the plots of sine and cosine in functions. Okay, that's it for today. Thank you guys for watching. If you like my stuff, donate, Patreon, PayPal, Amazon gift card. Go to my keyboard website, buy stuff, or buy my Emacs and JavaScript tutorial. Okay. Penrose tiling, yeah, abstract algebra plus plus. Penrose tiling, yeah. Good morning, informatic. Penrose tiling, actually, so maybe next time we're gonna talk about math, because there is quite a lot. Okay, let me show you where to go to. Okay, you go to XR Math, you'll find this page. Then there are some spectacular things here. That's a plot. This is what I call Borg cube, and this is actually a plot of a equation involving sine and cosine. This is a minimal surface. This is a polyhedron, rings for decorative purposes. This one is dodecahedron, and you have more of that. This kind of images are fairly popular. Sine and cosine plots, and again, this is inversion. This is called inversion. Okay, I need to talk about it some other day, but anyway. So, and this one is also very interesting, in part because let me show you. So you see, the whole image is made of one single line. Okay, now this image, so you can, today's generation, the millennial gen, with their idiotic fox, they also have graphics, by the way. So millennial gen, they have got what they call generative generative art. What is it called? What's the proper word? Generative art. What the fuck? They fucking create crap, like you splash piss on your screen, then that's artwork. That's those generative art. Those are like that. You just splash piss or spit on your screen. That's art. Instead of using your mouth, you use the programming language to do that. Just garbage. It's like art. That's today's generation, beginning with the millennial generation. So the millennial generation, they constitute a huge chapter in human history, about the change of people, change of norms, change of society. So we know each generation is a bit different than even back to 2,000 years ago. It also depends on the region, in China, in USA, in different region. You have different culture, different norms, and they change. And so the millennial generation is, I think, it's a big kind of change in human culture. So anyway, so these are, part of them is fractal snowflake. Okay, so recursive. Yeah, this one, a single line, it's done by recursive line replacement. And you have also recursive tiling, pinwheel tiling, very famous, very popular. This is a building using that as a theme, pinwheel tiling as a theme in Australia, Melbourne, Federation Square. And then you have fractals, then you have you have quite a lot. Okay, so all these are, I'm talking about this on this page. It's algorithmic mathematical art. Actually, so this is actually one of my big, I would consider one of the more, if I may say so, among my thousands of articles, this one is more important. valuable, algorithmic mathematical art. So first of all, I give you a survey of all different types of what's called mathematical art. You will see this if you are into math. So for example, there are competitions, visualization of math. So I give you a survey of all the different math arts and their techniques, how they are generated. Then I give you at the bottom, near bottom of the page, these are Celtic knots, Celtic knots, traditional decorative art in northern Europe, Scandinavia countries. But this one is something else though. This one is more Islamic. Different culture, they have different styles, and then you have Islamic patterns. Then you have Penrose tidings. Penrose tidings is one of the great. It's not just decorative art, but it's one of the greatest discovery a theory in mathematics. In fact, Penrose tidings. So anyway, at the bottom, then there is hyperbolic geometry. Okay, then the typical fractals. Then four-dimensional things, five-dimensional things, the shape of space. Then evolutionary programming, cellular automata. Then you have this Escher symmetry, group theory. Okay, symmetry and group theory. This one is I would say my favorite artwork of Escher. Of all MC Escher's artwork, this one is my favorite. Okay, then more MC Escher. This is about transformation of tiling. So anyway, at the bottom of the page, I try to give a definition of what is algorithmic mathematical art. Okay, in short, it must be mathematical. Well, it's hard to define. You can read it. Yeah, and, it's mathematical, and then by mathematical, essentially it means it must illustrate certain mathematical structure, or the artwork must have certain systematic mathematical structure. Okay. In contrast, computer-generated graphics such as these, that's not okay. That's crap. This is crap. These computer programmers, you guys love this. Like if you are in programming community, every day you'll see, oh, ray tracing. Let's do a ray tracing. The fucking idiots, computer programmers. They love this topic. But they don't. But they know nothing about you see all these other things I talked about. They never see. They might have seen a few polyhedron or MC Escher, right? But they have no idea what are they made of? How what's the structure? Why they don't know. But however, every fucking these programming nerds, Unix philosophy, they will love that ray trace. Ray trace is one of the big thing for computer programmers. C++ coders, they love this. So this is not an example of mathematical art. Okay, nor is it algorithmic art. Okay, I defined what is algorithmic artwork here. If you read the detail. So this is not. Okay, so some drawing, some image created algorithmically is not by definition, not my definition. Okay, that would not qualify as algorithmic art. Okay, but literally, yeah, it's algorithmic because it's done by a computer. So computer can do lots of things. You can do especially today, machine learning, AI, they start to paint, they start to generate pictures, and so you might say, oh, are they algorithmic? Not really. Well, in some sense, literally, they are created entirely by a computer via algorithms. But those algorithms, especially the AI, the machine learning the neural networks, they are not how shall we say, they are not they are not they are I think it's called statistical algorithms. They are not how do you say, predictive. There's a word I forgot, deterministic. Okay, they are not deterministic algorithms. In other words, what they come out will be different each time. You don't know what's gonna happen. That's those machine learning and AI and neural network stuff. So first of all, I give a definition of what's mathematical art. In short, it must contain it must contain, embed, or illustrate certain mathematical structure, such as this one, symmetry. So what is symmetry? If you study math, it's actually isometry. It's a group theory and isometry. There's a very technical definitions. Okay, and this transformation, they embed mathematics. In other words, these are mathematical arts. They embed mathematics. For example, this one, double score of fishes. So they are spirals. But what about spirals? Spirals, I can show you. Okay, spiral is one of the curve. This one is called. This spiral is called. This one is called equal angular spiral or logarithmic spiral. That meaning that they have a specific property for them to be whirled this way. Not bigger, not smaller. Every line, every point must be exact to qualify as this spiral. So this again, it's called equal angular spiral. Okay, you can look at my website. Okay, so I need to switch to equal angular spiral. Okay, so we rambled onto math, but what the hell, we have nothing to do. We have the okay, so these are equal angular spirals. These all of these, the top two rows are all from my website. So equal angular spiral, why is it equal angular? Because they have a specific property. You see, all the angles from a ray from the center to a tangent on the spiral is always the same angle. Doesn't matter which ray. That is why they are called equal angular spirals. Okay, let's go to the page. And okay, so that's there are many properties, and then you started to see equations. Okay, sine, cosine, and equations. That's the beauty of math, and you have to prove. Why is it equal angular? Show a proof. Then there's proof. And curvature, all these fantastic things. This is math. Okay, then it shows in nature. You see this often. In those math exhibit, or in science magazines. So anyway, equal angular spiral. So back to the so that's why this one is a mathematical art, I claim, because it embodies this mathematical structure. In this case, equal angular spiral or logarithmic spiral is the alternative name. And this one too, it embeds symmetry. There's and and cellular automata. This one doesn't. This one demonstrates the nature of this illustration, cellular automata, from Stephen Wolfram, A New Kind of Science, demonstrates the theory that deterministic systems may not be predictable. Okay, that's one of the great things you learn when you study cellular automata. So the system is very simple, deterministic, just like atoms in a universe. If you don't count quantum computing. Anyway, deterministic. Okay, but however, it's not predictable. Why? Because in order to predict it, you have to do the computation. And do the computation, it's so huge, it's impossible. Doesn't matter what kind of computer you have. the only way is to actually live it. So, for example, one thing interesting about supercomputers, like you study, you go to Wikipedia, you look up supercomputers, every year or two they have like top 10 the world's fastest supercomputers, USA, China, Japan, they take turns on the top. And one of the, so what do they what does those supercomputers do every day? You'll notice that one thing they do is that they 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 compute weather, like they run simulations to model weather, like they try to predict the weather. Imagine using supercomputers to not solve difficult math problems or computer problems or nuclear physics or thermal chemistry or whatever, but they use those supercomputers to predict weather. Why? Because, well, actually, because weather is actually one of the most important thing in society. You have to know the weather. Like if tomorrow is raining, whether you can go to your friend's house. It actually turns out to be one of the most important thing. And the other thing about it is that weather it's extremely computational intensive, and like you can predict next minute, but in order to predict 2 minutes after that, it the computational power is exponential, exponential growth. So the further away, the harder it becomes impossible. Like very quickly, it's impossible to predict 5 days. Like today, with our current technology, we can look at weather, like Apple. Apple has, every computer has this weather in 5 days. You go to the web, weather 5 days. But after a month, it becomes impossible to predict. So that's so that ties into cellular automata. That if you study this, you will know cellular automata. You understand why that is the case. Even deterministic systems may not be predictable, and generally it's just unpredictable, not predictable. So anyway, so then you have four-dimensional things, like this thing is four-dimensional thing, five-dimensional, and this is and different shapes, different shape of space topology. Okay, so all these images, I call them basically all images on my page. All these are mathematical artwork. Why? Because they embed or illustrate certain structure of mathematics, of mathematical beauty, pure. You will not see an animal face. You will not see a pretty bird. You will not see some pretty girls. Okay, it's all pure abstract images. There is immense beauty, a structure embedded in them. For example, knots. For example, you look at these knots. How are they connected? How are they weaved? That's a structure. Informatics. Okay, information. Okay, so anyway, so that's a definition. I give you some kind of definition of what constitute an artwork to be called mathematical. Okay, then I also define. I tell you how I should by when is a computer generated artwork qualify as algorithmic. Okay, now I'll give you the short version of it. In order for it to be algorithmic, what I call algorithmic, it must, your source code must correspond to, your source code, your algorithm, the way you create the picture must correspond to the structure of the image. Then, if that's the case, then your code is, what I would call algorithmic art. Program. A program that qualifies as, the program generating algorithmic mathematical art. There are details, this anyway. So that's I think so. Okay, that's it for today. Thank you guys for watching. Lots of rambling. Kina protein folding like Koike models. Yeah. Uh, okay. Bye guys. So today we talked for 1 hour and 10 minutes. Okay. Have a good day.